with number 17, you need to recognize really quickly that what we're being given here is equations. Okay, now that may seem obvious, but it means it needs to trigger something for you, right? We know that if we have equations, it's really good to have points because one of our strategies is to plug points into equations. And so we could start by just picking these dots. It's not pretty, but it's doable. And we can start plugging them in and seeing which equation tends to match up with the dots. But when they talk about a model here, we're really looking for basically the line of best fit, which they haven't drawn. So you might just want to do it. And it doesn't have to be perfect because, you're not perfect. So it's okay. You can just draw something that kind of goes through the lines, right? It's kind of like an average is what you want to think of a line of best fit as. There's statistical ways of calculating it. We're not going to do any of that. But it's supposed to kind of represent the general trend of the points. So estimate. Then pick a point that you kind of like. So I'm going to pick this one here, right here. Mostly because it's on some dots or it's on some corners of the boxes. And, who knows? It kind of matches where I ended up drawing the thing anyway. That was just a coincidence. But let's pick it out. And that is the point 8, 24. So what I'm looking for then is if I plug that point into these equations, I should roughly get stuff that works. So I would say for choice A, 26.2 minus 0.32 times the x-coordinate, which is 8, should give me roughly 24. So let's see. 26.2 minus 0.32 times 8 is 23.64. So pretty good. Now, I can't just pick that, though, because it's possible that this point also kind of works pretty well with some other equations. So I need to be certain and try it in a bunch of equations. And so we got to do everything. So here we got 18.2 plus 0.28 times 8. So 18.2 plus 0.28 times 8 is 20.44. It's not really great. Remember, we want it to be 24. It's worse. Maybe I just drew the line a little off, maybe. So I'm not going to eliminate it just yet. It's not terrible. So we'll see. But let's look at choice C, 25.4 minus 6 times 8. Well, I don't even need to plug that in the calculator. 6 times 8 is 48. 25.4 minus 48, that's a negative number. There's no way that's going to be right. There's no reason for me to have a negative number. The answer is positive 24, so this doesn't make any sense. Same thing here, 18.2 minus 6 times 8. That's also negative, both of these. So neither of them work. Now, if I were running short on time, I would just pick A here. It's closest, and it's probably right. But if I wanted to be sure, maybe I pick another point, something else that's kind of like easy to spot, kind of matches with the average line that I drew, right? And kind of maybe hits these little corners. So I also would want to pick something that's far away from the first point I took, basically because it reduces the effect of any error, right? I'm estimating in a couple of ways. I'm estimating because the point I choose might not be perfectly on a corner. I'm estimating because the line I drew might not be a perfect line of best fit. But no matter what, if I'm spreading my points that I'm testing out, the error kind of gets dispersed. If I'm close together, then the same problem with the estimating that I had for this point is going to carry over to this point because they're right next to each other. So whatever I'm estimating is probably going to be the same estimating error for both. Whereas if I spread them out, I might make a mistake here that causes some rounding issues, but it's unlikely that that same mistake is going to cause a problem all the way out here. It's just we're far enough apart. So piece of advice, but let's try it. Let's do this point. This is 26.16. So choice A would be 26.2 minus 0.32 times 26. So 26.2 minus 0.32 times 26 is 17.88. So again, not perfect, but pretty close. And then we've got 18.2 plus 0.28 times 26 again. So 18.2 plus 0.28 times 26 is 25.48. That's really off. So it was already the case that B was more off than A, but now I'm certain of it. A is the better fit. It best models the data. It's not perfect because I'm estimating, but it's pretty darn close, and I would be very certain of that. So if your problem was that you weren't getting an equation that worked, then maybe it was because your points were close together and you weren't like seeing the difference between the results, I guess, the points being plugged in. But the bigger issue is if you didn't know where to start, you've got to change the way you think about math. Because if you see equations, your first thought, no matter what that rest of that question looks like, should be, can I plug in points? Is there something that can go in here? Sometimes we'll need to solve algebraically. Sometimes we won't be given points and we'll have to be clever and either make them up or deal without them. But if there is a point to plug in, just do it. Don't think twice. Just do it. Plug it in, see what happens. Odds are that you're on the right track, even if you have no idea why. That's the best part of the plug points into equation strategy.